The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to GridGain Systems webinar, part 2 in memory computing for architects and developers. I'm Nicole Vangelua and will be today's moderator. Before starting, I will need to conduct a little housekeeping. Can you raise your hand with hand icon on the left of your screen if you can hear me? I only see one hand. Can the others hear me too? I see some hands raised, so we're good to go. On behalf of today's webinar presenter, thanks for joining us. I'd like to introduce our speaker for today. Akmal Chaudhri is a technology evangelist at GridGain. His focus is on Apache Ignite and the Apache community. If at any point during the webinar you have a question, please type it in the Q&A panel. Questions will be addressed at the end of the webinar. Please also note that your phones will be muted throughout the presentation. You've joined us today to hear about the essentials of in-memory computing for architects and developers, and we are presenting part 2 in our two-part series. At the end of the webinar, we'll close out by taking your questions. With that, I'd like to now turn things over to our product expert, Akmal Chaudhri.
Okay, well, thank you very much, and thank you to everyone who has joined. Now, where I am, it's very early in the morning, so I apologize if I sound a little bit sleepy or tired. It's just a little bit difficult getting up sometimes, and in this role, I have to travel quite a bit, and so it just means having to adjust yourself wherever you are to do these presentations. And so, you know, good morning, good afternoon, good evening, and thank you very much for joining. So for those of you who are able to attend part 1, it's been quite a wait. I think we did that at the beginning of July, was it, if I remember correctly? And so now we're running this one almost at the end of August. So it's been quite a gap between the two. But I think part of that is that summertime is always a little bit difficult. People want to go on vacation, so we deliberately arranged it to be at the most convenient times for, I think, for the vast majority of people. Okay, so in this part 2, then we'll cover a few more essentials and some topics that I think would be relevant for architects and developers. Let's quickly just recap what we covered in part 1. So we did an overview of Apache Ignite, this high-level view of its architecture, looking at a variety of the components and discussing in a little bit of detail things like SQL, for example, transactions, the compute grid, its persistence, the ability to integrate with third-party systems as well, in particularly very useful for transactional relational type systems, and where the cache and the database system can be kept consistent. We also looked at clustering and deployment, the approach that Ignite uses, some aspects of distributed storage as well, its cluster-based computing, and distributed SQL. So Ignite supports SQL 92, and that is gives it the ability to behave as a distributed database system with some of its additional capabilities, such as persistence, for example. And so in that mode, you can save data, query it. The SQL, of course, will work on in-memory as well. I mean, that's one of the useful features. So there are some advantages to this. And again, we'll drill down into a bit more detail into using SQL and some of the capabilities that Ignite has, such as co-located processing, which can be very, very useful in certain circumstances. Okay, so in terms of part 2 then, so we'll focus and spend a little bit of time on Affinity Colocation, very useful feature, and discuss then how this can work particularly well with SQL. So as I mentioned, Ignite supports SQL. To the syntax, in order to make use of some of the capabilities. So give some hints, if you like, to Ignite as to what it needs to do with the data. So in order to co-locate data, we have to extend SQL slightly, but it's not very, very difficult to understand. And again, you'll see some examples of that. Then we'll talk a little bit about distributed computations. So Ignite has a compute grid. Okay, it's one of the most mature and in early components of the technology, still used today for a lot of kind of map-reduce type operations. If you're familiar with fork join in Java, for example, this is the approach that it uses. We'll touch briefly upon machine learning. So I think there has been significant progress in this space since last year. So this was announced last year, and it was in beta for quite some time, and it's gone GA not so long ago, a couple of months back, but obviously development is proceeding quite significantly. So there's very good support for a lot of standard machine learning algorithms. There are code examples available as part of the download that you can get. And we'll talk a little bit about that. And I'll point you to some resources as well towards the end. So I've been looking at this area for a little while, for a couple of months, and I've written some blog posts and articles. And again, we'll show you where you can access these. And then very briefly, then we'll summarize and look at memory architecture and persistence, and then conclude the webinar for today. Okay, so let's start with this Affinity Colocation then. Okay, so this is a very useful feature. Oops, let me see. Okay, unfortunately, my laptop seems to have locked up there. Let's just wait for a moment. Okay, Nicole, I'm not sure if you can hear me.
Yes, I can hear you.
Okay, that's good. So the sound seems to be working. Unfortunately, the machine seems to have locked up. So as you can see, all I can see is the Apple logo there. So I should do my best to see what I can do to break out of this. There we go. So PowerPoint seems to have crashed, which is unfortunate. This has happened before. So let me. Okay, so let me just try and see what I can do. Oops, there we go. I wanted to try and get the okay, and Finder is crashed as well. So there we go. It's unfortunate. My apologies for that. It's one of these things that technology tends to just try to recover what I can. Okay, I apologize. I think that there's not much I can do here. The machine seems to be totally locked up. So it appears that sound is working and software is running, but the Finder is locked up. So the easiest thing to do for me is to really reboot the machine. So that means I will have to go offline and then come back up again. I sincerely apologize for that. It's one of these things that happens, unfortunately, from time to time, but that's technology for you. So bear with us. So I shall momentarily go down and then I'll join the webinar again as quickly as I can. Thanks for your time and patience.
Thank you for bearing with us. We'll start the webinar again in 5 to 10 minutes. Thank you. For those that have just joined, we're having a few technical issues with our presentation this morning, but we will be back online in a few minutes. Thank you for your patience.
Okay, Nicole, can you hear me?
Yes, I need to make you presenter, I believe, unless you have access to...
Yes, that's good. Yes, there we go. So there we are. I'm back up again. If you could do that, we'll get moving again. Thank you.
Right, you should be presenter now.
There we go. Okay, well, there we go. My apologies for that. Let's just see if we can. Okay. And then we want to open recent IMC Essentials Part 2. All right. So hopefully things will work a little bit better. One of the nice things about the Mac, as it starts up, at least it's able to open up the windows that I previously had in terms of applications, and so that's very, very helpful. Okay, so we covered this, Affinity Colocation. There we go. All right then, so let's drill down a little bit more and then talk about colocation then. Why is it a useful sort of feature? Well, think about certain situations. Let's say we've got information about countries and cities, and this is what we will use in the demo. Equally, we might have things like departments and employees, for example. And there may be other types of data that we have that has a certain relationship. And in a distributed environment, it's a good idea if we could maybe co-locate that data, because it tends to get processed together. And that's helpful because we want to avoid a lot of data movement across our distributed cluster. And this is the same kind of approach with other distributed technologies, such as Hadoop, for example, where essentially we're bringing the processing to the data wherever the data are, and then trying to minimize the amount of movement of that data across the cluster. So we'll look at an example of this, and the demos that we've got focus on countries and cities, so that's going to be very, very useful for us to see how this actually works in practice. Now, the other thing is that in terms of processing, then of course there are some benefits. So for example, I mentioned SQL support already. Then if we need to be able to do things like joins, for example, if the data are co-located and held on the same node, then that makes that process more efficient. Okay, doing the joins is going to be a less costly process than if we have to search right across our cluster in order to be able to find that data. And again, we've got some demos a little bit later on to show this in practice. Now, the other thing is that, so we're talking very much about data here so far and co-location, but what about processing? So computations and co-located computations are possible as well. So Ignite has this compute grid, which allows us to do some of those capabilities. And again, we'll look at that in a little bit more detail. The benefits that we get: reduced network traffic, which is great, okay, stops this data movement, and That's very helpful, and particularly if you've got large amounts of data. And then, of course, the key thing that we're looking for, again, is sort of performance boost and anything that will help in terms of doing that, regardless of the fact that, of course, Ignite is very fast anyway. If you're going to cache the data in memory, it will work. Things will work at memory speeds. But of course, once the data grows and we've got much larger cluster, then of course there may be certain issues that we have to think about and worry about. But nevertheless, overall performance improvement is what we really gain and what we're really looking for. Okay, so just to remind you, we talked about caches and partitions in the previous webinar. So think of a cache, it's just a terminology that's used. In a sense, it's just like a relational table, for example. It's just an aggregate, a collection, a way to be able to group data together somehow. At a slightly different level, though, Ignite uses this notion of partitions, okay? And partitions are kind of atomic. And here we can see on the left-hand side, for example, the country cache is made up of a number of partitions. And on the right-hand side, we've got a city cache also made up of a number of partitions. And the partitions are the actual units where we store the data itself, okay? And remember that from the previous webinar, Ignite is a key value store. And the value could be anything. It can be simple types, as is common with a lot of sort of key value stores, but they can be complex types as well. So you can store things like financial instruments, for example, healthcare records, just to give you a couple of examples off the top of my head. And so we'll look at this in a little bit more detail as we go along. The notion of caches is very, very important and extremely useful. All right, so here is an example of where we have two Ignite nodes, and we are doing this kind of storage of countries and cities. And here you can see that the data, certainly as far as the cities are concerned, is somewhat randomized. So we happen to have the examples of Canada on the left-hand side and India on the right-hand side. And of course, if you look at all the cities collectively there, they are actually from the two countries. So we've got Toronto, Calgary, Montreal, and Ottawa from Canada, and we've got New Delhi and Mumbai from India. But there is no co-location here. This is, it's purely random. Ignite takes a certain approach in order to store the data, and that's what it's done here. There's no special kind of consideration in terms of the cities being co-located with the country. So that's how it will do it. But if we're able to specify some additional sort of information, we can take advantage of that. Now, with no Affinity Colocation, so what will happen is that exactly as we saw in the previous chart, that we've got countries, and in this case, country ID equals 5. Ignite will decide based upon the cluster, it will hash the key, store it on some particular server node. And if we happen to have a city, and again, if there's no information that it knows about that there is some relationship between that city and that country, then again, it just applies an algorithm and then randomly decides where it's going to put that, based on the results of that algorithm, which particular node it's going to go on. So we're not guaranteed anything, it's purely based upon the hashing, how it's distributed, how the data are distributed based upon the algorithm that it's using. Ideally, this is the scenario that we would like to do, because we may be processing countries and cities together, and we want this co-location. So this is what we're really looking for Ignite to help us with and to be able to achieve. So the way it will do this then is that this relationship can be specified through providing, as part of this key here, the country ID. So in this case, for example, we've done this. So Ignite knows something about this data now. It knows that this is associated with this particular country, and the fact that it's stored the country on a particular server, for example, it can do the same for the city in terms of the co-location. We can take advantage of this additional information. And of course, other things which don't have that particular country code here, for example, we may have another city. it just gets allocated again based on some, you know, whatever country is assigned to that particular server node. Okay, so let me just show you some examples. Okay, so firstly, let's look at this notion of co-located joins and how actually this translates into SQL, for example. All right, so here's a join that we're doing. We're selecting some data. We have got some sort of couple of tables that we're working with, and we've specified that we've got Canada and its cities stored on one particular Ignite node, and India and its cities stored on another one. And notice, for example, keep a kind of a watch upon the SQL query itself, okay? Because when we look at a non-co-located example, just coming up very shortly, but the thing is that the query is exactly the same, all right? But the end result may be slightly different, and we'll see why that is in a moment. Okay, so let me exit from here for a moment. Okay, and just close this down. And you can see I've got quite a few windows open here. So let me just check to see we're okay. As you can see, there's a reasonable amount of free memory there. And we'll try and see if we can just free up a little bit more. So what I'm going to do is I'm going to fire up. Let's have a look. Okay, let me just launch this and show you a particular project. And again, towards the end of the webinar, I'll show you where you can download the code and be able to access this. Okay, so, oops, there we go. And it's loading the other project as well. Okay, so there we go. All right. So we can minimize this one. Okay, and we'll have a look at this one whilst we are. Okay, let's just take that down. Okay, there we go. Okay, so this is an IMC Essentials project created by Dennis Magda, and it is available on GitHub. Okay, so you can download this, and if you've got an IDE, again, just use the pom.xml file. You'll be able to load in the project. All you need is some Java, and it will build for you, and you can run this directly from within your IDE. Now, what I'm going to do here is firstly, start up a couple of Ignite nodes, and we can do this directly from this environment. Okay, so let's do that. Let's launch one. Okay, and just give that a moment or two to fire up, and then what we'll do is we'll launch another one as well. All right, so there we go. So there's our first node launching. That's fine. There we go. So at the moment, it tells us there's one server, no clients. That's okay. Okay, let me just shrink this down a little bit here, and let me fire up another one. Okay, so we've got a cluster of 2 nodes. There we go. Okay. Just give that a moment. And here at the bottom, if you're sharp-eyed, you can see there's a little bit of information here. So now it's got 2 servers. Okay, so these 2 nodes have been able to find each other. They've formed a cluster, which is running within this IDE, which is fine. So we've got our cluster up and running now. It's a small one, okay, but useful just for our demo purposes. It's absolutely fine. One of the things that we can do then is also we have this, let's have a look. What we want to do is open up a couple of terminal windows. Let me just close these ones and then just open a couple of windows here. Okay, and as part of the, oops, sorry, wrong CD apps. If I can type correctly, there we go. There is this thing called an Ignite web agent, okay? And This is something that we can use to connect using a REST interface, a web browser that gives us some useful information about the cluster, what's going on, what Ignite storage is, CPU utilization, so on. And so I will just launch this from here, okay? Just takes a moment or two. It's been able to find out the fact that there's 2 nodes currently running in our cluster, which is great. That's exactly what we want. And then what we can do then is using, let's have a look, open the console. There we go. Okay, so this now, if you look right in the top right-hand side here, it's just under where it says beta, you can vaguely see it says connected to cluster. Okay, so it's connected to a cluster, which has been able to find. Okay, so the web agent is talking to the cluster, and then this web browser is able to talk to the web agent. And if we can go to the dashboard here, we can get a little bit of information about what's actually running. Now, at the moment, obviously, my cluster is not doing anything useful, so you'll see that a lot of these lines are sort of fairly flat. There's no information here about any particular caches or Ignite storage, but I do have some information here about the nodes. So it gives me a couple of details about the node IPs, what version of Ignite's running, what start time, and so on. CPU, as you can see, and the load is quite low. So there's nothing there at the moment. I'm not doing anything to load the data or so on, but we'll have a look at that in just a moment. Okay, so let me just minimize this for a moment then. And what I need is another window. Actually, what I can do is I can go here because we can open a new terminal at folder. There we are. Okay, and what I have is access to a little bit of code here. Okay, and as part of Ignite examples and the code that you can download from the Apache website, there is this SQL Line Tools. It may be something that you are already using. Very, very useful. Okay, so allows you to do some types of SQL queries, create some tables, be able to connect to Ignite, and it's helpful because it's not a full-blown IDE or anything like that. It's a very tight, small kind of application that's great for sort of prototyping, being able to run some types of SQL queries. And as it says, it ships with the Ignite, so it's a very, very useful tool. And one thing that we can do then is use this to connect to Ignite using what's called this thin driver, and obviously the port, the IP address that I've given it is for localhost. Okay, and I can just hopefully run this. It's connected, it's in. And then what we can do is, again, as part of this, there is some SQL code that's shipped. And I'll show you that in just a moment, but let me just run this first, okay? So there we go. Now, this just takes a moment or so, okay? It's information about countries and cities, and then these tables are created and they're populated, okay? So that just takes a moment or two, all right? And as soon as that finishes, let me just show you what's actually going on. So if we have a look at this structure here, okay? You can see here that obviously first thing we do here is we drop the table if it already exists. And then we're creating this country table here. And if you're familiar with SQL, you see that this should look quite familiar in terms of the types, data types, character, integer, decimal, all standard SQL. Slight extension at the end here, which is what Ignite needs, these sort of hints in terms of what it needs to do. So we've got some information here about how many backups we want. In this case, we've specified 1. We can specify the name of the cache. Okay, so a cache is this something specific we talked about previously earlier in this presentation and in the previous webinar. So just Ignite storage, that's all it is. So we're saying that the name of that is exactly the same as the actual table value that we are using. Similarly, just a little bit further down then, what we're doing is we're creating a city table. So again, all standard SQL types. Now, there's a little bit more information here. So one of the things that we have here is this notion of affinity key, which we specified here. So this is the extra piece, excuse me, of information that allows us to do this kind of co-location. And if we have a look now back in our browser, so the data loading is complete. Let's go down a little bit and have a look. And indeed, we can see that there are a number of caches here, city, country, country lang, total amount of data, quite small, but enough for our purposes. And you can see that there is a primary copy. And you recall that just a moment ago, I showed you, backups equals 1. So what it's done is, because we've got 2 nodes running, it's created one backup. Okay, obviously, if we have a larger cluster, obviously a backup will still be created. But in this case, we know exactly where that backup is as well. Potentially, we can create more backups, so we can specify 2, 3, 4, so on. Generally, I think in distributed systems, though, it's a good idea to have at least one backup. Okay, so you have like the primary copy of the data and a replica held somewhere else as well. And the nice thing about Ignite is, of course, that it is rack aware as well, for example, and that's helpful, particularly when you're working with the data that can be distributed. You want to be sure that if the server where the primary copy is held goes down, it's not in the same rack that you've got your backup copy as well. Okay, so there are some contingencies and some, again, tuning and parameters that you can specify. So that's quite useful. Okay, so we've got our data in, we've got our Ignite storage. Now, again, level of activity is still fairly low here. There's not really much we are doing. But if we switch to the queries and have a look here, okay, so recall the query that I showed you on the slides. What we're doing is we're selecting some data across 2 tables, okay, we're doing a join, and specifically we're looking for Canada and India in this case, and we're going to print these results out, and we're doing a count of how many cities there are in each of these particular countries that we've got stored in this particular data set. So let's execute the query, okay? And there we can see some results. So you can see here that Canada, we've got 49 cities here, and for India, it's 341. Okay, so that's great. Now, let's just minimize this for a moment, okay? So here, again, just going back here, you can see that, again, standard SQL, little bit of an extension there, okay? So because we need to provide some hints to Ignite as to how we want the data stored, but beyond that, it's all very much following the ANSI and ISO sort of standards. This data, by the way, the actual sort of SQL instructions here, again, ships as part of the examples that come with the SQL line, okay? And then this is not a very sort of big file, but enough for our purposes. Okay, so that's great. So let me just move this out of the way for one moment here, and then have a look at this file here, which is identical in almost every way, okay? So certainly the create table and everything else is the same. Cache names, backups, all the same. But if we look down here, we can see in this case, this is using non-collocation, okay? So we haven't specified the affinity key here. So if we were to create this data, and we were able to run the query, we may get slightly different results. And let's just try that, okay? So from our SQL Line tool, again, let's now, let me just copy and paste this, okay? So this second file, this second script that I've got available, if I now just execute this, so what it will do is drop these tables that already existed, and then just populate it again using these new parameters that we specified. Okay, so that just takes a moment or two. Excuse me. Okay, so let me just park this out of the way here and then just give this a moment or so to complete. There we go. Now, one thing I should have done, actually, probably, but it's okay. We'll try it and see if it works. If not, then I can easily shut down the cache and do this again. But let's go back to the dashboard, and then again, just scroll down. Okay, so here we can see, yeah, that in fact it's the same if you look and you were sharp-eyed in terms of keeping an eye on the data. So again, those tables have been dropped. The new data has been populated in, and again, we had the backups equals 1, so that's fine as well. So there's a primary copy and a backup copy, that's okay. Let's go back to our queries, WellDB, and again, just scroll down and have a look at this query here. And if we execute this, notice that the result is now different, okay? So remember, we had higher numbers for both Canada and India. So what's going on here? So the thing is that because it's not using this colocation, these joins are taking place locally, but we're not getting the complete result. And so one of the things we can do here in this GridGain console is say allow non-collocated joins. Okay, and if we were to run this again, there we go. So again, if you remember the results that we had previously, this now matches 49 and 341 in terms of the count for these two particular countries. Okay, so switching back to our slides, and so this is the, I think, a useful and having a look at this non-collocated join. So you can see that the SQL query is identical. Our result set is slightly different, okay? Because what's happening is that the joins are being done locally on each node. But then we can specify, okay, you know, if it's incomplete, go away and look at what else is available across the cluster, and it's done that. When we've done that and reran the query, as you can see, we got the correct answer back. It's simply that using this non-collocated joins, we have to think a little bit about how we're going to use the data, and you know, if it makes sense, that's fine. But I think in the general case, we probably want to use the first approach in terms of collocation. If we know that we're going to process that, much more useful, because it doesn't have to search across the cluster to be able to you know, perform these kind of distributed joins. It can do them locally, and that again saves resources, saves time, boosts performance, and provides a number of other benefits. So that can be very, very useful. Okay, so let's go down a little bit further, have a look at distributed computations. All right, so I mentioned the compute grid a little bit earlier on. So this is one of the most mature components of Apache Ignite. And as I said before, if you're familiar with things like MapReduce, for example, in Java, things like fork join, then this really works along the same principles. So the idea here, as you can see, is that we've got some work that comes in, a job. And that job then is broken down into a number of tasks. Ignite figures out what resources are available. In this case, it just happens to be that these two nodes that we have on the right-hand side for our Ignite cluster, they are of sort of equal power and equal resource. And so, you know, in theory, then divide and conquer, okay? So tasks are sent to these two nodes. We would get the result back in half the time. However, Ignite is a bit smarter than that, okay? So it can look to see what nodes are being underutilized, for example, where resources are available that can, in that particular server node, can do more work, okay? That's a very, very useful feature. And of course, all the standard things that you would expect in cluster computing, things like load balancing, for example, automatic failover. So in the event that some parts of our cluster go down, we lose some nodes, and again, it can do that recovery for us and help us in terms of keeping you know, the cluster going. The benefits of of course, of doing things like replicas and keeping multiple backups, again, can be very useful. In the previous example, you saw that we had backups equals 1. So in our 2-node cluster, for example, if I lost one of those nodes, then it's okay, because the data are backed up across the 2 machines. If I lose one, it doesn't matter, all the data are still available. That would be okay. Zero deployment, mentioned on ability, it's called peer class loading. So if we have some client code, for example, that we've modified, we don't have to worry about restarting our cluster for it to recognize those changes in the code. Ignite, again, is very smart enough to be able to load that Java code in and be able to run it without having to worry about, taking the cluster down, restarting it again in order for it to acknowledge the changes that have taken place. Now, this is a very useful feature, I think, in environments where maybe you're doing a lot of testing, for example. So you could be writing code, testing its capability against the some test data. Obviously, be a little bit, somewhat careful in terms of how you use this in a live environment. You want to have some control about what code gets deployed and how often. And so, this is really policies and procedures, and then enforcing those within your enterprise environments. You need to think about that very carefully. So very, very powerful, extremely useful feature. And I wrote a brief blog post on this. And again, we'll show you where you can read up a bit more about this. But, extremely useful feature. And as I said, certainly in a lot of testing environments, if you want to try things out, be able to modify code, be able to run against different data sets, and then see what the results are quickly, that's great. Obviously, be careful, as I said before, how you use this extremely powerful feature in a live environment. Okay, so let me just go down here, and again, let me just switch to the this here now. What we have at the moment, if you remember, is our non-collocated data. So I want to show you a little bit on sort of collocated processing and compute broadcasts. So let's just make sure that we got the right data in. So I will make sure that we've got our collocated data back in now. So it will drop those tables, repopulate them, but do so as we had a little bit earlier on in terms of collocation. So that's done. So that was fairly quick. That's great. Okay, now we've got a very small cluster of just 2 machines. Okay, so sometimes this can work well. Sometimes the results can be a little bit unpredictable, but we can certainly try it and see what the output is. So let me just show you a little bit of the code here. Okay, so we've talked about collocated data. Now let's look at collocated processing. Okay, so this is the ability to process based on the previous chart that I showed you, so the compute grid. And in this case, for example, we're doing some processing. We're running a little bit of SQL as well. And then we can check to see how that processing is being done. Is it actually making use of the collocation? And we can try that. So as I said before, sometimes these things work. It just depends on the size of the cluster, which in our case is very small. I'm a little hesitant to launch any additional server nodes. You saw what previously happened with PowerPoint, just lack of resources. Okay, so let's have a look here. All right, so what's happened here is if we're looking at the output for one of these nodes, what's happened is that one node has no collocated processing taking place, but the other node seems to have handled both of those in terms of the 2 specific countries that we're looking for. So if we have a look here, you can see it's done the processing, and we've got some output here, number of cities 49 again, and if we go down, number of cities 341. So that happens to have run on the same node. That's okay. I mean, these results are sometimes predictable, sometimes unpredictable. It just depends on how the cluster has been configured and how it's actually running. But that's fine. I mean, it can be very, very useful, I think. Another thing we can try, again, broadcasts. Okay, let's have a look at this. We can broadcast a message across and again be able to retrieve information about all the cluster nodes that we have available. So here, for example, it's been able to retrieve information about the different nodes that we have, the fact that we're running on the sort of Mac OS environment, the username, which version of the JRE is running, and it's actually sent out, I think, a hello world message to each of the nodes that we have. And there we go. So there's one on that node, and if we look there we go, is the other hello world message, hello node, that's appearing on the other one. All right, so there's some sort of nice capabilities, sort of powerful features that come as part of the compute grid that allows us to interrogate the cluster, be able to find out what's running, what sort of resources are being utilized, what version of Java as you saw. I mean, there's a whole load of other sort of parameters, features, information that we can garner. We just pulled back some basic information, and that was just okay for our purposes as far as the demo is concerned. Okay, so let's move on and get back to our slide deck. All right, there we go. Okay, so typical client-server processing then, and that's been the model that's been in use for a very long time. Initial request, fetch data from remote nodes, process the data set locally. That can work reasonably well in certain circumstances, but I think this idea of collocated processing really makes far better use of the resources that we have available in terms of cluster computing, using the power of each machine to be able to do certain level of processing, and then being able to take the results from each, combine them, send them back to the client, and you again, being aware of what sort of utilization each of those cluster nodes has. So Ignite, as I said a little bit earlier, is smart enough to figure out if a particular server is being underutilized, that it can do more work, it's got more resources available, then it can take advantage of that, and that can be very, very useful. So again, I think very powerful and very useful feature. All right, so machine learning then. Let's talk a little bit about this. So this machine learning grid then has been in development for some time. Okay, so it was in beta for a number of months and went GA earlier this year. Supports popular machine learning algorithms, decision trees, regression. The goal here is really to support the kind of algorithms that are commonly used in a lot of business applications. And so the examples that are provided are exactly for that. And I'll show you that in just a moment. The key thing here is that the way that these libraries to support this machine learning, the code has been implemented to take advantage of distributed processing. So again, it's not simply having to run something locally on one machine. Commonly, I think, for a lot of machine learning algorithms for small scale sort of processing, it's okay. A laptop may be sufficient. And sometimes as a data scientist, if you're working on these type of problems, that might be enough. Okay, I mean, typically what you'll do, you'll take a sample, you'll split it into test and training data. It may be enough to run it on a local laptop, and you'll get some results back. You can build some models, and then you can try and scale that up to a larger size. The benefit that you get with Ignite is that once you're working with, say, large quantities of data, and perhaps a scenario might be, let's say, data being streamed in, for example. It could be transactions, could be IoT data, for example. Ignite is acting as the sink. That data, the data are arriving. As the data arrive, you could run some SQL queries on that data. You could run some analytics. You could run some machine learning algorithms. And a good example, which I recently just wrote about, was fraud detection, for example. So credit card fraud is still a problem for a lot of banks and financial organizations. So one of the things that we can do, for example, is that as transactions take place in real time, then if we've developed some type of machine learning, classifier to say what is the, what are fraudulent transactions and what are okay transactions, then that can be applied to the data as it's arriving in real time. The other thing is that because machine learning is very much an iterative process, what they've done with Ignite, particularly in the recent releases, is they added this notion of what's called partition-based data sets. So the thinking there is that typically when you're running a machine learning algorithm, context may change as you're running that algorithm. It may be doing a lot of iterations, but that context may change. If you've been running an algorithm for some period of time, let's say it's been running for, say, 20 minutes or half an hour or something like that, perhaps it's particularly complex, or it may be working over a large amount of data. If some parts of your cluster go down, for example, you lose a node or two, then it can use this notion of partition-based data sets to continue working. So that there is redundancy and failover built in there. You don't have to rerun this code and start from scratch again. So that's a very useful and very handy feature. And again, particularly I think for streaming data that are coming in, again, there's some benefits that you can gain as well, because inevitably hardware tends to fail at some point. There can be other issues in terms of network failures and so on. And if you in a distributed environment, these are the things that we have to put up with. But failover and recovery is, as I said, Ignite supports this. Partition-based data sets will help, particularly when you're running machine learning algorithms at scale and working over large amounts of data, can be very, very useful in those scenarios. The other advantage that you get now is that in the past, the problem with trying to do machine learning with Ignite is that you had to ETL the data. Essentially, it couldn't help you. So you had to take it out, use third-party tools to be able to run whatever you needed to do in terms of your machine learning, and then perhaps copy the results in, or you put them into some other system, and that can be an expensive operation. I mean, dealing with large quantities of data, this is not really an ideal solution. So the fact that now you can run machine learning algorithms side by side with any of the other components that you have, and it all goes back to this idea of the whole being greater than the sum of the parts. These components are integrated, they work well together, and therefore streaming data, for example, applying SQL, running machine learning, all of these can sit side by side. They can work on that data, and you can do that very, very fast again. So some great benefits there. So distributed algorithms, support at the moment, certainly in terms of Java and C++, REST, and so on. Scala is, of course. If you are working in some of these other languages, such as Python and I believe the support for these is coming along, and it's certainly on the roadmap. Beyond what the machine learning does, then things like deep learning, for example, so interested in working with things like tools like TensorFlow, for example, support for that is coming up as well. So this is something to look forward to. Okay, so memory, architecture, and persistence. Okay, so very, very briefly then, let me just cover this. Oh dear. Okay, apologies. This is terrible. My laptop seems to have locked up again, unfortunately. Let's just see what we can do. I can't even get my cursor back. Nicole, can you hear me?
Yes, I can, yes.
Okay, my apologies. I'm afraid my laptop is locked again. So this is terrible. What can we do? There we go. I'm unable to get the anything back again. So bear with me again. I'm sorry. I'll have to shut this down and reboot it again, and you'll need to give me make me presenter again. So
okay. I apologize to everybody that's on the line right now. We have another technical issue that comes from the fact that my colleague is out in the US for the moment, and therefore it makes webinar broadcasting a little difficult. Please accept our apologies. He will be back online in a few minutes.
Okay, Nicole, I'm back.
You are the presenter.
Thank you very much. Okay. All right, guys. Well, my apologies for that. It's just, I think, not sure what's happening, but obviously some serious memory leak or resource utilization or issue with PowerPoint there, and just seems to lock up the laptop. It's been generally okay. Okay, so actually we've almost done with the slides, but let me just try and just open that and then just find. And I think what I'll do is just open this up, and rather than trying to run it in presentation mode, there's actually just a couple of slides left. Let's just try and not risk it. Okay, so Ignite native persistence. Okay, so one of the features that we actually discussed in the previous presentation that we did was this persistence capability that Ignite provides, and so it uses this notion of write-ahead logs. Okay, so it doesn't do in-place updates. Each node keeps a set of partition files, okay, because that's what it uses for recovery. It's responsible for a certain part of the overall data cluster's sort of data. And again, there's good documentation and information available on this in terms of persistence, storing large quantities of data. So if we've got, say, terabytes or even petabytes of data, it's highly unlikely that we want to cache all of that data, but we may want to keep that. So just yesterday, for example, I did a presentation. There were a couple of guys who attended the meetup, and they are interested in building, this kind of virtual reality environment. And they want to be able to store data continuously over a long, long period of time. And so they're not going to delete anything, but it's just going to add and add and add. And so in that situation, probably you don't want to cache everything, but you want to persist, certainly want to persist everything, and maybe want to cache some of that data. So that would be a great kind of use case of where this would work. Okay, so I think we're almost at the top of the hour, but let me just briefly give you some resources. Okay, so dzone is a great place to go. So if you look at, just do a search on my name, again, we've got the GridGain blog as well. So there's a whole bunch of articles that I wrote very recently on Ignite's machine learning capabilities, fraud detection at scale, KNN classification, linear regression. There's genetic algorithms are supported as well, sort of fabulous application of how sort of evolution and biological sort of entities, these chromosomes and genes and all these things work, and how this can be applied to some types of complex problems. Ignite supports that capability as well. Other things, then, as I mentioned before, my colleague Dennis Magda. So if you look on GitHub /D Magda. Okay, so Dennis has this IMC Essentials, which contains the kind of some of the demo code that we've got, plus a few other things as well. He does a little bit of the machine learning, but the SQL, key value compute. So it's a kind of a cut down version of what you would get with the actual Ignite distribution, but helpful if you attended the previous webinar as well. And this one, then this essentially gives you the main parts of this. And I think that's pretty much it. So we do have the GridGain blog site, of course, and there's articles there that have been published recently just focusing on Apache Spark, for example. But again, all of the machine learning and the other codes. The peer class loading, again, you can find the article here. It was published last year, quite short one, but very useful. Okay, so Nicole, I think I'm at the top of the hour, and apologies. I think we may have time for perhaps one question, and then if there are any others, please do contact me directly. And again, apologies for the crashes there. Again, it's beyond my control. Sorry about that. It just seems to be a memory issue with PowerPoint. It just seems to lock up the machine. So do we have any questions, Nicole, if you're able to see?
One question which has come in is how seamless is it to upgrade to new version? Is there anything we need to be aware of as potential issues?
Oh, yes, good question. So there is good documentation upon the Ignite website in terms of what steps you need to do. And typically with each release, there will be some guidelines if you want to upgrade. Something might be specific to that particular version that you need to be aware of. But as far as I'm aware, generally it's okay. So I've worked with a couple of different versions, and I find that changing one, installing the new version generally works pretty well. I've not had any significant problems. On my machine, for example, I've got multiple versions which I use because I try out a couple of different things using different versions. But as far as I'm aware, it should be pretty easy process. Any gotchas or specifics, they will be very well documented to tell you what particular cautions or precautions that you need to take before upgrading to a newer version. But as far as I'm aware, it should be fairly easy process to do so.
Thank you, Akmal. That is all we have time for, I'm afraid, today. So I would like to thank our speaker today, and thanks to each of you for joining us and for your participation. Again, should you have any questions, address them to Akmal Chaudhri directly, and I'm sure he will be taking the time to answer them for you. Thank you and have a wonderful day.
Yeah. Thank you, everyone. Thank you.